can start working on that problem. Okay, and maybe after the class also. And if in case you have got the answer, okay, then you can feel free to post it in Google Classroom or in our next class. Fine. So what we will do now is we will continue our discussion and we will see as to how we go ahead with the five variables. Okay. So of course the complexity is going to increase. Okay. But we will have to look into what best can be done. Fine. Maps of more than four variables are not as simple to use. Number of squares becomes excessively large, and the geometry for combining this in squares becomes more involved. So what do you understand by geometry? Geometry is nothing but the complexity, or the number of squares is increasing. So because of which, what is happening? You will have to look for proper grouping of ones. If in case there are no proper grouping of ones, of course you can go ahead with grouping less number of ones as well, but then the equation that you get is not optimized. Okay, it is just like how do I say, a cycle needs only two wheels. Okay, but if you're using about four wheels, okay, in a serial fashion, it doesn't make sense, right? The optimum one is going to be two wheels, right? With two wheels also the cycle, you can use your cycle. So similarly here, okay, you can get equations, but those are not going to be optimized. Okay, so that is what I'm trying to say here. Fine. For five variables map, we need 32 squares, as I told you previously. It's going to be from 0 to M31. Okay, so min terms 31, 0 to 31, which is 32. The rows and columns are numbered in reflected code or gray code sequence. Okay, so 0, 1, 2, 3. Okay, next 4, 5, 6, 7. Okay, why are these changes now? This changes is because we need to have one bit change. This is going to be the same here, 0, 0, 0, 1, 1, 1, 1, 0. This is going to be the same. But towards here, okay, towards your CDE line, what is going to happen? I need just one bit change corresponding. Now, if I compare the first one and the second one, 0, 0 is common. Only 0, 1 at the end, at the LSB, lowest significant bit, is getting changed. So similarly, if I compare this and this, okay, 1 is same, the first 0 is same, only the middle 1 is getting changed. Okay, so in that fashion, we have to actually put this. So using this this weightage of cell is very important. Okay, so 0, 1, 2, 3. Okay, and again here you get 4, 5, 6, 7. Okay, so it's like how you fold the sheet here, fold the page here. Okay, at this line we should fold, and then you will actually get to know. Then 8, 9, 10, 11. Okay, then 12, 13, 14, 15. Then I'm coming down 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So this is how. So all my ones, see here, AB is 1, 1, and my CDE is 1, 1, 1. So this is my highest value, which is M31. Is that clear, students? Are you clear with this numbering, the weightage of cells? Please respond. Yes? Okay, fine. Thank you. So, moving on. It's nice if you can make note of this. Okay. If not at the end of the day, probably in some time, just after lunch, I will try to post the video. Of course, yesterday's class also I need to post. Okay. So together I will post and share the link. Sorry, Bhargav, I couldn't get you there.
Do we need to remember the cell numbering? I mean, the cell order?
Yeah, if you remember, it is good, Bhargav, because quickly you can actually start solving problems. Okay. Of course, for your 2 raised to 2, okay, it's very simple. 0, 1, 2, 3. It's very simple. Then 2 raised to 3, okay, it becomes a little complex, wherein you have 2 to the 4, 4 to the 8. You have 8 squares, right? So 16 also is somewhat okay, right? So when we go to 32, the complexity increases, right? So it is just like, let me probably annotate, and we will try to understand as to what I'm. See, we are folding the sheet across this. Okay. So if I fold a sheet across this, okay, I am bringing this 8 squares here. 1, 2, 3, 4. 1, 2, 3, 4. There's 16 squares. Sorry. 3, 4, 1, 2, 4. Okay. So these 16 squares are coming here. So it is just like this. Okay. 0, 1, 2, 3. This is fine. Next, you go with 6. Sorry. Just a moment. 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So I am breaking it into half here. Okay. So 6, 1, 2, 0, 1, 2, 3. Okay. So when I have a mirror image of this, okay, I need to have a mirror image of this, okay, because I'm folding it this side, okay. So which means this is sitting here. So if this is sitting here, okay, so it's going to be 6, 4, 5, 4, 5, 6, 7. Okay. Similarly, I start with 8, 9, 10, 11. So once I get that, since this is folded, okay, you will be starting from here, 12, 13, 14, 15, because it's folded, right? I am folding portion, this portion I am folding on top of this square,
Sir, if we
on top of
fold it,
square.
then the M6 will match to M0 now.
No, it is just an imaginary way of explaining. Okay. So it is not that, it is sitting on one top of the other. You have to imagine in such a way that, just like how we had for, 8 squares, right? Like how we had 0, 1, 2, 3, right? 4, 5, 6, 7. So imagining this concept, okay? So as your complexity, as the number of squares increase, the complexity or the way of thinking becomes different, okay? So I am folding this on top of this, and it is like a mirror image. So what I'm trying to say here is I am starting with 0, 1, which means I am starting from my left hand side, isn't it? But here I am starting from my right hand side. Why is it so? Because this is actually a reflected image. So when I say this is a reflected image, I should start from here. Are you getting what I'm trying to say? 12, 13, and then 14, 15. So which means I'm starting from right hand side here. This half I'm starting from left hand side. Is that clear, students?